Hello, I'm Jack Lee with Loudon Sunling, and this is Lab 9. This is for the class Opti380A, or TA's Lab9, and this lab has two parts, diffractive apertures and measuring laser beam divergence. In the first part of the lab, we started off with the setup shown on the picture to the right, and attempted to perfectly align the heating laser with the optical system. Then, to complete our experiment, we placed a variety of apertures in the second lens, including a single slit, two double slits, a square slit, and a circular aperture, along with a triangular slit. For each of these apertures, we observed the image of the Fraunhofer pattern, the image of the aperture, and a few transition periods in between. Overall, when comparing the Fraunhofer pattern with a circular aperture to the theoretical expectation, we observed high error, which can be attributed to our inability to properly align the laser within our optical system due to Fresnel reflections, back reflections, and our laser being too powerful. This last issue caused most of our photos to be oversaturated. Here's the photos of the double slit. The triangle. These photos are much better than the double slit. You can actually see some of the transitions. The Fraunhofer much better than in the double slit. Here's the square. Again, you can see the Fraunhofer and the Fresnel regions along with the image of the slit on the right side there. And finally, here's the circular aperture. You can see that the Fresnel and Fraunhofer are just not very great. The image was just oversaturated. We had a very hard time. And you can see in the images there's some aberrations and some imperfections that were on the lenses that caused them just overall to not be very clean. You can see this in the data here. The sombrero function fit just does not look very close at all. We believe this is because the laser was too high powered, and additionally, there seemed to be some internal aberrations coming from the system because even when our laser was seemingly perfectly aligned, there were still a lot of errors in the system.
We were tasked with calculating the divergence angle, beam waist diameter, and numerical aperture of a laser using a beam profile aligned with a heating laser. Furthermore, for our procedure, we identified a starting distance, Z of R, of 2.3 centimeters and made measurements of the waist diameter for both the X and Y directions for distances 2.3 centimeters to 42.3 centimeters in 22 increments. From our recorder data, we were able to calculate all of our needed values using Python code. Using the Python code, we generated these graphs which represent the curve fit Y and X axis curve fit beam width versus distance, which resemble an exponentially increasing function which is theoretically accurate. Our average calculated results were that the beam waist diameter is equal to 368.4 microns, our divergence angle was equal to 0.00547 rads, and our numerical aperture was equal to 2.73 times 10 to the negative fourth. Consequently, you can see in our average calculated results to the right that we did a good job of centering our laser on the beam profile because the results are very close to both the X and Y